Hello, welcome to a new video series for CSCI 1061 Programming Workshops 2. I'm recording this series as a chance to give you a little bit of exposure to how I solve problems in C++ pertaining to the topics that we're going to be covering in the course. I want to put up front that this is not meant to be a replacement for attending lectures. It's also not going to be a place where I'm going to talk too much about the theory or the concepts in the course, but rather jump directly into covering some of the different exercises that I'm going to show off in class. I do recommend giving yourself some time to try out all of these exercises before you watch me do it, because if you watch me first, you're kind of spoiling your chance to actually see how much of these concepts you already understand and how much you need to get help with. Really, the best way I think to use these videos is after you've given yourself a chance to try and solve the problems, then you can see either how I do it differently, or if you happen to get stuck along the way, you can see, what stage did you get stuck at and what hurdle did you need to jump over in order to get to the end of the problem. So without further ado, we're going to delve into the first week, which is just going to be review. We're not going to be covering anything new in this first week of class. We're really just looking at the fundamental things that we covered in CSCI 1060. Most of that course is going to be completely necessary for this course to work. There's a couple topics like recursion that we're not really going to go into too much detail in this semester, but the majority of the things that we did last semester are going to be super relevant this time, so you need to know them. So first off, we're going to delve into our first problem, which is reviewing the ideas of variables in control flow, if statements, storing data, variables, and so on. And with this, we're going to write a program that, given a positive integer variable, determines whether or not that number is prime. Prime number is a number, the smallest prime number being 2, where there are only two factors, 1 and itself. So 1 does not count as a prime number because it only has a single factor, 1. 2 is the smallest one, then there's 3. 4 is not a prime number because it can be divided evenly by 1, 2, and 4, and so on and so forth. So let's see if we can write a program that's going to do this for us. So in week 1, let's make ourselves a little notebook. Probably for most of this course, I'm going to be using the regular CPP files, but just to do some review, I think maybe I'll go with a simple notebook. So we need to figure out if a number is prime. So let's say, 2, we should be able to figure out that 2 is prime, and 3 is prime, and 4 is not. And then we can try with some other examples to make sure our code is working. Okay, so I have my number. How do I figure out if my number is prime? Well, first of all, if my number has something that goes into it, means it divides evenly, then I know that, and that number is not 1 or itself, then I know that that number is not prime. So what I'm going to do is kind of assume that it is prime, and I'm going to write a Boolean variable called isPrime, and I'm going to assume that it is. And now my goal is to see if I can find a number that divides into it that isn't 1 and isn't itself. So, well, let's suppose for a second I'm working with a number bigger than 2. Maybe I'm working with something like 2,000. What numbers do I need to check to see if they divide into 2,000 evenly? Well, 2, 3, 4, 5, 6, 7, so on and so on. But what's the biggest number where I can actually stop after that and say I don't need to go any further? You can think about it for a second. And the answer is 1,000, because 1,000, we can kind of tell, divides into 2,000 evenly. Will 1,001 divide into it evenly? No, there's no way, right? Because 1,001 times 2 is now bigger than 2,000, which means that once I hit 1,000, any number after that, I don't even have to really do any math. I just know for sure that everything between 1,000 to 2,000 won't specifically 1999 won't divide into 2,000 evenly. And this is fairly obvious. So what this does for us is set a upper limit to where we actually can stop looking for numbers that divide into it. Now what about the smaller limit? Well, the first number we should check to see if it divides into it is 2. So we have the bounds where the lowest possible factor is 2. The highest possible factor is, well, where do these numbers come from? These are all the numbers after my number divided by 2. So the highest possible factor is number over 2. That is the range that I'm looking at. Now, in order to figure out how to go through this range, I probably want a loop, right? So we're going to use a for loop. Normally we would start with our loop at I equals 0, but if as soon as I divide by 0, I'm in a bit of trouble. And also divided by 1, well, 1 is going to go into everything, so that's not particularly useful. So if I start at 2, and I want to go until I reach number divided by 2, now I am covering all the possible factors that I need to concern myself with. 2, 3, 4, 5, and everything up to number divided by 2. If number modulo I, so if you've forgotten what modulo is the result of the remainder after division. So if I have, for example, modulus, if I say, 15 modulo 6, that's equal to 3 because 6 times 2 is 12, and 12 plus 3 is 15. 3 here being the remainder after I try to divide 6 into 15. 6 goes in once and I'm left with 9, 6 goes in again and I'm left with 3, and that's the remainder. So if the remainder is 0, that means it divides in evenly. So number modulo I, if this is 0, this means that I evenly goes into my number, and it is not prime. So is prime is false, and I can break out of the loop because I don't need to do any more math. I know it's false. So let's see. Is it prime? No, pretty clearly, right? 2000 definitely got 2, in fact, is going to actually divide into it quite evenly. What about, let's say 66? We can tell this. Actually, let's pick a non-even number. 63. 3, I think, divides into this evenly. Is this prime? No, it is not. Now let's pick an actual prime number. Let's say 19. This is prime. When I go through 2, 3, 4, 5, 6, 7, 8, 9, none of those divide into 19. I don't need to check after 9. I can stop at 10 because there's no way anything between 10 and 18 will go into 19. So I know for sure that this is prime. Now, there is one small mistake I made, which is, what if my number is 1? 1 is not prime. And in fact, I believe 0... we actually don't have to worry about 0 because the question says a positive integer value, so I can ignore 0 and negative numbers. But we have a mistake, which is that it says 1 is prime. This is not true. So I need to make a small correction, which is I guess we can do it here, where I say is prime equals true. Instead, what I'm going to do is I'm going to say, I guess the simplest way to do it is if number is 1, we will say this is false. Otherwise, we'll say it is true. Now this also has a bit of a mistake, which is that I need to actually define this variable outside of this if statement, so I'll just do it up here. I will remove the types, and now it will say that 1 is not prime, which is correct. 2 is prime. 3 is prime. 4 is not prime. And you can go on and check, and this should work for all the positive integers. And there we are. This is example 1. Okay. So let's go on to our next exercise. Functions and files. So we now have a bunch of code, and it's kind of just dumped into a Jupyter cell. Not really the most elegant. Let's make it a function. Instead of using just a variable called number, let's actually make that a parameter of a function. And we will then write another function, and that function is going to open up a file, read all the integers inside of it, assuming there's one every line, and compute the average of the prime numbers in the file. So let's do this one step at a time. The first thing I need to do, we'll grab all this so I don't have to go back to it. Actually, let's put this at the top of my example as well, just so we have a reference to what this is doing. Should probably zoom in, huh? It might be a little easier to read. Okay, so that was example 1. We'll drop that. Let's make another, which is example 2. Yeah, I'm happy with that. And here I need to make all this into a function. So the function is going to determine if something is prime or not, which means it's going to return a Boolean value. So my function is a Boolean. We're going to call it int is prime. It's going to take a number. We'll space everything forward. So given a positive integer value, determines if it's prime, does all the work here. I think I missed a brace somewhere. Oh, I have to return is prime. So I realized after I made my function that it's supposed to return a Boolean value. I forgot to. And so this says control reaches end of non-void function. My function's not void because it's supposed to return a Boolean. I should return a Boolean. I want to return if it is prime. Okay, there we go. Make sure this works. We're going to say int is prime 4. It is not. How about is 7 prime? Great. Okay. So here's our function. I didn't have to do too much work to put it together. All I had to do was take most of the code that we had there, remove the initialization of a number variable. It's now just a parameter. It's going to return a Boolean, and the Boolean it returns is whether or not my number is prime. So now that I have this function, I want to do another part, which is what I'm going to copy into here. Put the code from the first exercise into a function. I did that. Write a function that, given a file name, opens that file, reads all the integers inside, compute the average of them all, and print them out. So a few steps are going to need to take here. First of all, I'm going to need to pull in some libraries. If I'm going to be reading in and printing out stuff, I would like to have some libraries to help with this. So I'm going to need to include iostream. I need to include fstream. These are my libraries that have respectively input output as well as files. Now, given a file name, so I need to write a function for this. So I suppose we're going to need to write a function. It doesn't say that my function returns anything, so this will be a void function. We will call it compute averages. It's going to take as a parameter a file name. So in this case, we'll take a, I suppose, a string. This will be file name. We need to open it and read all the integers inside. So to open the file, I need to do if streams. This is an input stream. My file. We're going to open my file. And it is called file name. And now for each number in the file, I'm going to add them all together, compute the average. So that means I need to keep track of how many there are. So account, which is going to start as 0. And we're also going to need to have a sum, which is also going to start as 0. Now, we'll also need a variable to keep track of the number that we are currently reading in. So we'll call that this number. And what we're going to do is we're going to write a loop that goes while I can read in a number. So while, and we're going to take my file and read into this number. So now this loop is going to repeatedly take a line from my file and put it into this number. And when there are no more numbers to take, the loop will stop. Now I have a number. I need to increase my count by 1, and I need to increase my sum by the number. And it says compute the average of all the prime numbers in the file and print it out. Now, keep in mind here, I've done 2 integers. If I try to divide, it will use integer division, which is not what I want. So I want to make sure that I correct for that, which is why I'm going to use typecasting to ensure that my sum is modified to a double. In fact, probably the easier thing is to not even use typecasting. I'm actually just going to make this a double variable. So that way, while I read in the integers, I can add them to this. And when I do a division that uses a double variable, it's not going to use integer division. So I've written all my numbers. So now my average is going to be the sum divided by the count. And I can output the average of the numbers is the average. How does that? Does that look good? Okay, I made a mistake. I forgot to put std : before string. What else did I forget? I also forgot to put it over here. Okay, what else did I forget? No matching constructor. I think I must have messed up the format for this. Let me think here. What if I pass this? Do I need parentheses? No. What if I give it a file name? Is that okay? Now it's not complaining about this, it's complaining about this. What if I don't do this for now? Okay, no, it's still pretty unhappy. I think this is just a case of me forgetting my my syntax for opening files. What did I forget? I forgot. Oh, this shouldn't be a problem. Let's see here. What if I put this in? Oh, you know what I think it might be? Yeah, okay. I know what it is. So, and I'm reminding myself the problem. When I was teaching 1060, this actually was around the time that I stopped using notebooks, and it's because Python notebooks, or Jupyter notebooks, are really, really bad at handling file I/O. So I'm actually going to take all of this and put it into a CPP file. Probably better that I start doing this now, because there are going to be other cases where the notebooks really have a lot of issues with things, and I'm actually pretty convinced that if I put this into a CPP file, it will work perfectly okay. So there's my int prime function. Here is this code. Here is this. Just copying everything over. We're going to delete this notebook, actually. I suppose I'll leave it, and it's obviously not going to work, but this code here should. And then to double check that this is going to work correctly, we're going to write a main function. And in my main function, we're going to, I guess we'll do nothing for now. I just want to make sure this compiles. So let's see if I can compile it. G++ example2.cpp. Yes, I forgot the std : before the end line, which goes here. Again, okay, compiles with no errors. So this is definitely a case where the notebook is really just kind of letting me down, which is fine. We were going to abandon it. I don't think it's worth using it outside of some specific examples. So let's go back to our code here. Now let's make sure this works. So first of all, I need to actually have a file to open. So let's make a new file. We're just going to call this numbers. And we'll have 1, 2, 3, 4, 5. The average of this should be 3. Maybe let's actually add one more. So this is 7, 14, 21 divided by 6, which I guess we'll find out what that is. And let's try running this. So file name is numbers.txt. And we will call compute averages on the file name. I will compile. Seems okay. We will run it. Average numbers is 3.5. 3.5 times 6 is 18 plus 3 is 21. Yep, that sounds about right. So this is, I actually left, I'm not going to make any edits to this in terms of the video, because I think it is a good chance to sort of show that this code here matches exactly what I have over here. I can copy and paste it just to confirm. But you can see there's a bunch of errors, and the reason that these errors are showing up is actually to do with kind of the inner workings of how Jupyter Notebooks are working, namely that they have a lot of problems dealing with files outside of themselves. So in this case, this line of code here, which works perfectly okay in a CPP file, completely shuts down in a notebook. So for the purposes of this course, I would probably discourage you from using notebooks for anything serious that you're trying to make. Maybe if you're doing some like really tiny short code examples, it's okay. But in this case, for files in particular, it's not even worth really trying to figure it out. And it works perfectly okay with a CPP file, fortunately. So there we have our example 2. Notebook, not so reliable, but the CPP file works perfectly okay. We can move on to the next one. Okay, so example 3. Write a program that sorts an array of strings into alphabetical order based on the last character of each string. For example, hello comes after to do because L comes after D. And the reason we're comparing L and D is because the last letter of each one is O, which is the same, which tells us nothing. So we need to make a function that compares two strings in alphabetical order based on their last character. Then we're going to sort an array of strings into order using that, that comparison. So let's start with the first thing, which is make a function that compares two strings and determines which one comes alphabetically first based on the last character. So to make a, I think in this one I will make a notebook, and we'll see if it fails. Always worth experimenting a little bit to see what happens. So this is example 3, and we're going to take this and try to build it. Okay. All right, so let's start with making our function that compares two strings this way. We're going to need IOStream because we'll be printing stuff out. And I'm going to try to avoid using namespace std for lots of this course, but for now, just to save myself a bit of typing time, I'll put it in. However, I will probably in a much later video go over why you actually don't really want to do this all the time. For now, I think it will be okay to leave it. And let's do a bool compare strings. And we're going to have string s1 and string s2. And what this is going to do is return true if S1 is less than S2 based on the last letters. So, for example, to do is less than hello. Okay, so how are we going to do this? Well, the first thing we need to do is figure out how we're going to compare the last letters. So let's suppose for a second that we're only comparing one letter at a time. We can worry about the other stuff after. If I want to look at the last letter of each character of each string, well, how do I even get that? Let's set up some variables, and we'll say s1 last. How do I get the index of the last character of s1? Well, I know the length of s1, which is s1.length. This is not the index of the last character, though, because if my word is, for example, hello, hello may have a length of 5, but the index of the O is 4, so it's the length minus 1. We'll do that for S2 as well. Okay, so now I have the last letter of each one. And now, if S1 last is greater than S2 last, I'll return false, because clearly it's the case that these are not in the correct order. And now I can use this greater than to do simple alphabetic comparison, because if you remember, oh, sorry, I don't want S1 last. I want S1 of S1 last. And this is S2 of S2 last. Let me go back a second. These are the indices, not the characters themselves. So I need to get the character. To get the character, I need to use this index of the string to grab a letter. And the letter has a numeric value as well. A, for instance, I think has a value of 65 or something like that. Let me double check. Okay, whatever, that's fine. The value of A is, I guess 97 for a lowercase, capital A is 65. So all these letters have numerical values. And if I want to compare, say, A, which is 97, and B, which is 98, I can just do a simple greater than, less than, and that will tell me if they're in alphabetical order. A is less than B, according to alphabetical order. So now I can say, okay, well, if S1 is out of order with S2, then clearly it's the reverse of this. Alternatively, I can have the reverse. And if that's 2, I can return true. Sorry, flip the sign. There we go. So if S1 comes before S2, based on the last letter, then great, they're all good. Now the tricky part comes otherwise. And so otherwise, if it's the case that, I don't even need to write else actually. If it's the case that they are the same, then what do I need to do? Well, I need to go to the previous letter. So what I actually should do is take S1 last and reduce it by 1, and S2 last and reduce it by 1. So now I'm looking at the second last letter. And now I need to do this again. So, okay, well, if I want to do this over and over and over again, I probably should use a loop. I don't know if I want to use a for loop, though, because it's not quite clear to me which of these is going to run out of letters first. For instance, if I'm looking at hello and to-do, well, to-do will run out of letters before hello does. So I want to make sure that I stop when one of these has reached, when one of them hits a negative number. So here's what we'll do, is we will say while S1 last is greater than or equal to 0, and S2 last is greater than or equal to 0. Select all this, intact. And now what this will do is it'll look at the last letter and compare them. If they match, we'll go back a step and then look at those letters and compare them. And if they're the same, go back a step. And at some point, one of these is going to run out of letters. Let's suppose, for example, that the words I'm comparing are, so if, I guess as an additional note, longer words come alphabetically last, e.g., hello comes after LO. So if you look at the last letters of these, O's match, L's match, E matches, and then I run out of letters here, but there's still an H left. So alphabetically speaking, hello should come after. And using that rule, what I will do is I will return if S1 last is less than S2 last. Basically what I'm saying is that if S1 has fewer characters than S2, then, and all the letters match, then that seat should be okay. So let's try this with some examples just to make sure this actually works. Also, why is it mad? I think it's mad that I have these, if I have this in the same as the include. So I'll just put that there and this here. Run, everything's okay. All right, so let's compare some strings. So compare strings hello and LO. This is false because hello, LO should come first. So if I flip them, it's true. We said that hello comes after to do. So does to do first and hello come second? True. Okay, great. So we now have a function that's going to return true if this string comes before this one based purely on the last letters. That took a little bit, but we're not done because we also need to write a program that sorts an array of strings in alphabetical order based on this ordering. So now we need to write a sort. There's lots of ones out there. I'm going to stick to using the least efficient but most easy, I think, to code one. And we'll call this, We'll call it bubble sort because it is a bubble sort. And it's going to take a string array and the length of that array. We'll call that size. Sort a string array of size elements using the above comparison method. Okay, now how do I sort an array? To sort an array, there's a number of different ways to do it, and the bubble sort way to do it is you go through the whole array comparing each pair of elements next to each other. If they are out of order, you swap them. Every time you go through the array, you ask yourself, did I have to swap anything? If you never had to swap anything, it's in order and you're done. But if you had to swap something, that means you're not finished, you have to go through again. So, I will have a Boolean called sorted, and it's false because that initially is not sorted. And we're going to write a loop that goes while it is not sorted. The first thing I'm going to do is going to be optimistic and say, hey, maybe it is sorted. And now I need to ask the question of, can I find a pair out of order? So to find a pair out of order, I need to go through my array. I is 0, I is less than the size minus 1. I'm not going to compare the last element to the one after it because there isn't one after it. So I'm only going to look at all the elements and the ones that come immediately after them. Since the last one has nothing after it, there's no point comparing it to anything. Anything that comes after it, I should say. I'll compare it to the second last element. For each element, does it come in the correct order compared to the one afterwards? So if not compare strings, did I call it compare strings? Yes. And the strings I'm comparing are array I and array I plus 1. I'm comparing each element of the array to the element that comes after it. If they are not in the correct order, I need to swap them. To swap them, I'm going to use a temporary variable called temp. It's going to store array I. Then I'll replace array I with array I plus 1. And I'll put the temporary variable into array I plus 1. So now they've been swapped. This hopefully should be something familiar to you. I think we did a few examples of swapping stuff in 1060, so it shouldn't be anything new. Also, I had to swap something, so it is not sorted. And that's it. What did I mess up? Compare strings. Yeah, I'm passing it. Oh, sorry. This should be a string array. Sorry, the brackets go over here. There we go. Got to remember to put those brackets to indicate it's a string array, not a string, not a string called array. Okay. Let's run all this from the start. Make sure everything is okay. Now let's make a string array. So string array is hello. How are to do hello. Okay, so this is my string array. We will bubble sort my array, and it has 1, 2, 3, 4, 5, 6 elements in it. And we'll see what it has after. Call to array is ambiguous. So probably I should call it something other than array. Call it my array. Oops, my array, my array, my array, my array. Oops, remember to put all the my arrays in. I think array may be a special word that C++ likes to use, so better to not do it. Okay, and now let's see, is this in the correct order? So remember, we're looking at the last letters. Well, E, the last letter of R, comes before all the other ones. All the other ones end in O's or W's. So this one comes first, W comes last, so it should appear at the end. Does that make sense? To do comes first because D comes before L. These all have double L's. However, E, or LO, has the fewest letters, so we said it should come first. According to this, capital H comes before uppercase H. It is kind of an arbitrary choice, but that's, I guess, the rule that we're using. And now we have everything in the order that we want. And that's our example. Okay, let's move on to the last one. So just going with 4 examples because we're trying to keep things a little short this week. Dealing with pointers and vectors, both incredibly important topics, and the reason that C++ is something that we're covering in these courses is because of the use of something like a pointer and vectors, especially for managing dynamic memory, which we'll talk about in a bit. But for now, let's look at this example. So make another notebook, C++. Well, it says using a main function. Actually, so let's not use a notebook. Let's use a proper C++ file. Example4.cpp. Let's close everything else. Okay. Write a function that takes a vector of strings as a parameter and returns a vector of string pointers, where each pointer points to the matching string in the parameter vector. Sounds a little bit confusing, but I'll hopefully try to break it down for you. And we'll verify it works by calling it a main function. So first of all, let's include our libraries. We need IOStream, we need vector, we use namespace std. We're gonna have a main function later. Write a function that returns a vector of string pointers. So the type of this is vector of string pointers. And the function, we can call it whatever we like. So we'll say generate SP vector, generate a string pointer vector. And the parameter is a vector of strings. Okay. Now, it's going to need to return a vector of pointers. Each of those pointers needs to point to the matching string in the parameter vector, and we'll verify this works. Now, something to keep in mind is that when, first off, I should give this parameter a name, so we'll call it vec. The other thing to keep in mind is that if I just pass this vector, I am passing a copy of this vector. If I have a bunch of pointers that point to matching strings inside here, those vectors are actually going to disappear. That's not very good. So I want to make sure that this actually is going to refer to the original vector that I'm looking at. I want to pass this by reference. So I'm going to add a ampersand. I forgot if I add it here or if I add it over here, but I'll leave it there, and if this is incorrect, I guess I'll find out. I need to make a vector of string pointers. We'll call this spvec. And we're going to be returning that when we're done. Let me double check I have the right syntax here by compiling this really quickly. Example 4. Okay, no, I was right. The ampersand goes over here. Okay. So this is the type of the function. It returns a vector of string pointers. It's called generate SP vector. It takes a reference to a vector of strings. And this is really important because I want to not be copying a vector and handing that over. I want to be sending over the reference to the vector so that all of the pointers I'm generating inside of here are actually going to point to something useful and not something that's going to disappear. Now, I need to push into this vector the pointers that I'm looking for. So for I is 0, I is less than the size of my vector. Now I can take vector I, this is a string inside of my vector. I can get its address, so this is the address of that. And that's going to be a string pointer that I want to put in. So this is my string pointer. And it points to that. And I'll push that into my SP vector. Push back SP. So now this will push into my SP vector pointers that point to my other vector. And I'll return it. Now to make sure this works, I need to make a vector of strings. I'm going to push into it some words. Hello. how are you? And then we will say vector string star spvec equals generate sp vector with my vector. Let's check that the syntax is correct. Seems like it's okay. Now, rather than run this in here, I want to pass over this code to my other favorite programming platform, which is Python Tutor. Python Tutor is going to be very helpful for us because it's going to show us exactly where in memory everything is happening. Okay, let's see what's going on here. So we got some vectors. Actually, is this going to show us everything? I have a nasty feeling it might not. Okay, yeah, I think this might actually hide a bunch of the content for us. Oh, maybe not. No, it is. Okay, I was hoping that Python Tutor would be more helpful for this, but I think because we're using strings, it's not going to be particularly useful. So that's okay. I would rely more on Python Tutor for things like integers and arrays. Vectors and strings, it tends to hide a lot of things in the back end and not really show you what's happening. So let's actually just stick with what's going on here and kind of work our way through verifying that this code actually works. So if I did this correctly, what I should have is my spvec should have a bunch of pointers in it. And each of those pointers, the value of it should be a place in memory. So first let's double check that's the case. So the memory addresses of the pointers are there are 4 of them. Actually, I can use the size of the vector. And we'll just output the value of what's there. So for each element in my string pointer vector, print out its value. Let's see what happens. So here's a bunch of them. Looks like they're all taking up about 32 bits each. So those are my memory addresses. Now let's do the values. The values pointed to by the pointers are, and to get what's pointed at them, I need the dereferencing operator, which is the asterisk. So now go to what's at that pointer and print that out for me. And there they are. Hello, how are you? Okay. This, I think, is a good example to demonstrate a few really critical things that I know were tricky for some students in 1060. First of all, the use of pointers, just in general. Passing by reference, I think if I remove this, some weird stuff might happen. Let's actually see what goes on if I do this. So if I remove the ampersand, will this work? No, you actually get segmentation fault, core dump, and the computer doesn't tell you why nothing worked. And the reason nothing works is that if I don't have this ampersand here, I create a copy of the vector and I pass it to my function. All the stuff inside of here, grabbing the addresses or grabbing addresses of a copy. When my function is done, that copy is kaput, it's gone. And so when I go over to here and I start trying to enter these, to type out these memory addresses and values, well, this is pointing to junk data. It's pointing to stuff I'm not supposed to be accessing. And so the whole thing kind of just crashes. So to ensure that doesn't happen, I need to have this ampersand here so that I'm giving a reference to the original vector that has hello, how are you? And that is going to work out as I want. Okay, so that's it for week 1. Keeping it a little short for now, but next week we're going to have a lot more examples that we're going to be covering, and we're definitely going to accelerate the course probably after the 3rd week. The first few weeks we're just going to be doing a bit of review of the most important parts of 1060 that are relevant for 1061, but starting in week 4 we'll be covering brand new content that's going to be really relevant to the focus of this course, which is going to be on programs that are just bigger than one file. Right now, all of the exercises we did today are pretty short, and you can really just put them in a single file and everything is okay. But as we'll see in this course, we're going to be building bigger and bigger examples, making things that build on top of each other, and sort of getting closer and closer to our ultimate goal, right, which is to be able to write programs that are going to be practically useful in the real world. And we're going to get there. So just follow along, and hopefully these videos are helpful. I'll see you in class. Bye-bye.